All right, hello everyone. Welcome to day 2 of section 2.6. I know we already went through one day, but I figured the best way to enter day 2 is just to real quickly review day 1. I won't spend a lot of time on it, but just wanted to make sure that all the concepts we learned the first day are fresh in your mind here. So with 2.6, we start with these distance time graphs, and they're a specific type of scatter plot you're going to see quite often in high school going through the years. A short form is called a DT graph, or distance time. And what we did to start was we learned about a fish finder, and that brought us into exactly what we were going to do in the video with Mr. Smith and I setting up the CBR, which looks like this right here. And we kind of brought it onto the desk, and we were walking in front. I was walking as Mr. Smith was narrating, and you learned about how walking in front of a motion sensor looked on the graph. We went through these 6 predictions with the actual graphs. You can review that video. Then we went through each of these in order to better understand exactly what was going on and how to move, so you can review that in the last video. This was a little bit of homework. I'm not going to take up this one per se, but this was for homework. Just explain how you would move. But I will touch on this right here. We did this one already, and this one here is one that you are going to have to do. So I will take this up in class if there's any problems, but it's just, again, in the video, you can see how the first one's done. You can do the second one here. But real quickly to review, this is something new. Don't worry about copying it out. You don't have this in your notes. But just to review real quickly, how would a person have to move to make each of these graphs? I'll real quickly go through each of them. This person would have to start away from the CBR a little bit and walk very slowly away. All right, the line is not too steep, which means slow, and it goes up to the right, which means away. So slow and away. This person started right at the CBR, still walked away, but notice the steepness of the line. It's much steeper than this one. This person went fast. This person started away and walked away slow. This person started right at the CBR, the distance is 0, and walked away quickly. This person started away from the CBR and walked towards the CBR, not that quick. It's not too steep of a line, so not that quick, walk towards the CBR. Notice the distance is getting smaller as we move along the line. And this person started away from the CBR and walked towards it very slow, very, very slow, hardly was moving. That's how slow they were going. These next 2 straight lines going across, they both start away and they are both not moving. That flat line across means not moving. The difference between these 2 is this person started much closer to the CBR than this person right here. Next, this person started away from the CBR. They walked away very slowly. They stopped for a short time, and then they walked all the way back to the CBR quickly. They went back the other direction, walked away, stopped, walked towards. Slow, fast, no movement. This person increased their speed while walking towards the CBR. Notice that this is not as steep as this. We're getting quicker. So start away and increase your speed as you're walking towards the CBR. This person is not walking at a constant speed. That's why it's curved. And then this one here you cannot do, because when you get to this point, you are starting to go back in time. So you cannot do this one here. I usually do this as a warm-up, but just to refresh your memory on what the CBR, the movements and what they look like, I thought I would go over that. Your homework. Describe the motion shown in each distance time graph. Write a few sentences. I would say that this person started a little bit away from the CBR and they walked away from the CBR slowly. This person started the same distance away as this person, but they increased their speed while walking away. This person was a uniform speed. They went the same speed the whole time because of the straight line. This curved line means they're increasing their speed up to the right. If this person decreased their speed, they would start quickly and then they would go in this direction here. Okay, but the other way, this is not as steep as that. So they're increasing their speed. This person started much farther away and then didn't even move. Okay, just stood still. This person started quite a ways away from the CBR and they walked pretty quickly towards it. They ended up right at the CBR. I know that because they're right back to this origin, and notice that that's 0. We're right on this line. This represents 0 away. This person started a little bit away, and this is kind of 2 curves. The first curve is increasing their speed as they walk away, and then all of a sudden they start to decrease their speed as they walk away. So they increase to decrease. And then this one starts right at the CBR, and they decrease their speed walking away until they stop for one quick moment, and then they increase their speed walking back. All right. A canoe starts from a dock, paddles to the end of the lake and back. Notice here, this is not a CBR. This is not the motion sensor. This deals with the distance from a dock and the time. This is still a DT graph. It just doesn't deal with the motion sensor like in class. It deals with time in hours and you paddling a canoe away from a dock in a lake, maybe a cottage of some sort. So if we take a look at the questions, how long did this trip take? Well, this person left at 0 hours. They went all the way up, across, and back, and they got back at 4 hours. So the whole trip was 4 hours. How far is it to the end of the lake? Well, you end and you stop right here before you start to go back. If this person went all the way to the end of the lake, it's 6 kilometers away. Then they go another 6 kilometers back. What does the flat portion of the graph represent? It's the exact same as with the CBR. That person stopped. And was the canoe traveling faster on the way out or on the way back? Well, let's take a look. It took them 2 hours to get out. They stopped for half an hour. And then from 2:30 to 4, it took them 1.5 hours on the way home. 2 hours on the way out, 1.5 on the way home. They were traveling quicker at this second line right here. So this person probably traveled out, took 2 hours to get to the end of the lake. They stopped for half an hour, maybe for a little drink of water, a bite to eat, and then they went quicker all the way back and got back in 4 hours. 2 hours out, half an hour break, an hour and a half home, and that's their trip. Lastly, you're holding a rangefinder pointed at a nearby wall. Describe how you would move in order to match this graph. Well, in order to match this graph, you would start a little bit away. You would walk away slowly, then you would walk back towards slowly, and then you would stop. How would the distance time graph change if you walked faster? Well, you would have a steeper line, and then stop. Steep means faster. How would this graph change if you walked slower? It would be flatter. You would be flatter, and then straight. And how would the graph change if you stopped sooner? Well, you would go up, down, and then you would start that flat line quickly, or more quickly, I guess, earlier in the graph instead of down here. If a rangefinder is available, okay, we don't have one. So those are your homework questions, and just kind of refreshing your memory on this. So right here, communicate your understanding. State which phrase best describes each line segment. So take a look. A represents this point here, B represents this point, C is this point, D and E. So you refer to the first line segment as line segment AB, the next line segment as BC, the next one as CD, and the last one as DE. Here they are right here. You need 2 letters to represent a line segment. So which one represents no movement? Which one? AB, BC, CD, or DE? And the answer is CD because it is a flat line. Which represents the fastest movement? It looks close, but C, B, C, and D, E are close. But you see how this line goes down and it goes 1 across and 2 down? Over here goes 1 across and it doesn't quite go all the way 2 down. This is your steepest line right here. This one is longer, you travel longer, but this is steeper. Even if I take this, just to show you, I'll grab a red line here. And if I draw this line, the steepness of it right there, and if I just flip it the other way, I'm going to flip left to right. And if I were to bring this back, see how it's a little steeper than BC? Your steepest line is DE, which shows the slowest movement. That would be AB. And which is the backwards movement? Well, this is away, stop, and then back towards. BC never gets used here. We're going to clone this one again. and DE goes right here. Okay. These graphs show a person's distance from the wall. Describe the motion. Well, this person started away. They walked slowly towards the wall, and then they stopped. Then explain how the motion in each of the other two graphs differs. So how does this differ from this one? I think most of you see that this is a flatter line than this one, so you're traveling faster here, and then you stop. But notice where you started too. Do you see you started at this line here? This one you started just a little bit farther away. So for this graph, you start just a little bit farther away and you go steep, which is fast towards it, and then you stop when you get kind of close to it, but not quite all the way there. And then how does this one compare? Well, this one starts way up here too. So this one starts away and you decrease your speed as you're going towards the CBR. So you go really quickly at the start and you slow down, slow down, slow down, slow down at the end. You're barely even moving at the end, okay? Couple communication questions. So now here's what you're to do. You're gonna finish these handouts on DT graphs, but each of these doesn't really deal with a CBR per se, it deals with different situations. This is like a distance time graph, but the distance is the amount of sunflower seeds you eat. So Ian and his friends were sitting eating sunflower seeds. Each person had a bowl with the same amount of seeds. The graphs show, or the graphs below show the amount of sunflower seeds remaining in the person's bowl over time. Explain how each person eats their seeds. So you can see time and the amount of seeds left in their bowl. So give a little quick story on each one. Question 2. Michelle's late for school. She runs halfway to school, then gets tired and stops for a short rest. Then she walks the rest of the way. Which one of these two is this graph? And whichever one you don't use, write a story for the unused graph here. How would Michelle have to move to represent the unused graph? One of them matches this story, the other one you got to create a story for. Okay. Next, describe the motion represented by this graph, time and distance. You can just use a CBR, but explain exactly what's going on for question 3. Next, Mark walks to his friend's house. Partway there, he realizes he forgot his CD at home. He runs back home to pick up the CD and then walks back to his friend's house. The bottom is time. On the side is distance from home. Draw yourself the graph of this situation. Okay, what would it look like? And question 5 is a great question, but you have to understand it. Below the following graphs, there's 4 of them, 1, 2, 3, 4 graphs. So below the following 4 graphs are only 3 stories about walking to your locker from your walking from your locker to your class. So this is the time, probably in minutes, I would say, and then your distance from your locker at school. Now, obviously, you're not using lockers this year, but picture the distance from your locker getting to your class. There are 3 stories and there's 4 graphs. It says 2 of the stories match 2 of the graphs. So your first job is to match up which 2 of these stories match 2 of these graphs. That is going to leave 2 graphs left over and only 1 story. So for the 2 unused graphs, the ones that don't match 2 of these stories, you are going to create stories for them. So whichever 2 you don't use, you then create 2 stories for those graphs. And if you're matching up, like I said at the start, 2 of these with 2 of these, if they match up, then you've got 1 story left over. You've got to make the graph for that story. So all of these are practice on DT graphs with movements, fast, slow, forward, back, not moving. And your job is just to finish these handouts on section 2.6. Okay, hope that goes well. Finish all the handouts. There may even be one more handout that I don't have here, but finish all the handouts remaining with 2.6. We'll take up any difficulties in class. So hopefully all is going well, and we'll see you guys in class very soon.